batteries. Everyone pretty much has a cell phone. Cell phone generally is going to run off batteries. And these batteries are going to have to be powered. And the thing is, we are running into an energy deficit. Currently, right here, 2012, shows how much energy we are currently producing among natural gas, coal, nuclear, biofuels. We are running into an energy deficit. That's what we're going to be talking about today. First, we're going to be talking about the energy crisis. Next, we're going to be talking about nuclear power. And third, we're going to be talking about what we can do. So, to start off, the energy deficit. According to the United States Census Bureau, in 2012, there were 314 million people in the United States alone. By 2051, 39 years from now, this is going to increase to 400 million people. Each one of these people are going to be using cell phones, computers, TVs. This is only going to increase to our energy deficit. As you can see, this is a projection by 2040 by the United States Energy Information Administration. This is projected that of our energy, 30% of it will be natural gas, 18% of it coal, and 8% nuclear. This graph also includes fuel for heating your house and everything else. So your car is even under petroleum and other liquids. So we've gone over a little bit of the energy deficit. We've also seen a little bit about where we're going to be, have to take this energy, what we're going to be, increasing this to. The energy deficit, currently, we are using 17.3 quadrillion BTUs of coal in 2012. This is going to increase to 18.7 quadrillion by 2040. 9.3 trillion cubic feet of natural gas per year in 2012 to 11.2 trillion by 2040. So we've seen a little bit about our energy deficit. This is going to increase. And right now, we're going to be using natural resources, non-renewable resources. So what do we do? Well, the answer to this is nuclear power. Nuclear power is a safe form of energy. There has been, it is a safe form of energy. When we compare it, every year, 1 terawatt of power is enough power for the entire world for 5 months. Okay? So 1 terawatt year, enough power for the entire world for 5 months. On average, to produce that amount of power, coal will kill approximately 375 people. Hydroelectric, 950. Nuclear, on the other hand, 8. 8 people will inevitably die to produce this type of power. 8 people is a big difference between hydro and coal. It almost doesn't even register on the chart. Now, there have been incidences such as the Chernobyl nuclear power plant. The Chernobyl nuclear power plant was a grave disaster that affected a lot of people. But this is due to the fact that Russian nuclear power uses a lot less safety measures than American nuclear power. In fact, a lot of our safety measures that we put in place don't even exist over in Russia. A notable incidence of this would be 3 Mile Island. 3 Mile Island was an incident in the United States, and it is the worst nuclear disaster we've had in the United States. Of it, 2 million people were affected by 1 millirem above the background level. What does that mean, 1 millirem? 1 millirem, the normal background level that you would normally have in that time of year would be 100 to 125 millirems, according to the United States Nuclear Regulatory Commission. 100 to 125. Your average X-ray is 6 millirems. So 1/6 of a chest X-ray is how much these people were exposed to. That is a testament to the safety measures that we have in place in the United States of America for our nuclear program. But what else? We have the fuel rods. The fuel rods that go along with these. According to the United States Energy Information Administration, we have 160,000 spent fuel rods. If we were to take these fuel rods, go to Memorial Stadium right here at KU, we could stack them 5.5 yards high and fill the entire stadium. This is a lot less than the original 9.3 trillion cubic feet of natural gas that we have to use. And this is all of the nuclear waste we have ever produced. All of it. So, we've seen a little bit about our energy deficit. We've seen a little bit about nuclear power. What now? What do we need to do? Well, currently, KU, and this is off of KU's actual website, the universityofkansas.com facilities. Here we can see the amount of energy used in 2006. The blue graph represents natural gas, the red graph's electric. Of it, the University of Kansas, 95% of the cost of $9.7 million we spent that year, 5.5 million of it was just to electricity. That's 5.5 million per year that we are spending at the University of Kansas for electricity. So what do? Build a nuclear power plant. That's what we need to do. A nuclear power plant, enough to cover the actual energy usage of KU, would cost us $1 billion. Now that sounds like a lot to everyone here, right? $1 billion. 80% of it, though, can be covered by a loan through the United States government. 80% the United States government will cover. The other 20% we can fund by the students themselves if we were to increase tuition per year over the next 10 years by $720. Now, that would be to fund it completely by the students, okay? What we could also do is add in grants and even get the city of Lawrence potentially to help pay for this nuclear reactor. Not only that, but having a nuclear reactor here at campus would allow for us to increase the educational benefits to people who are wanting to get a degree in nuclear engineering and science. So, this helps the whole school by twofolds, decreasing our energy footprint and giving the opportunity for the students to actually learn about nuclear energy and all that by having a nuclear reactor here on campus. So, $720 per year for the next 10 years. If we want to go and fund this so we don't have to worry about an energy problem and have our own phones, computers, and everything else potentially shut off in the future. So, let's go and see about getting our tuition raised a little bit so we can have a nice, bright, clean future with nuclear energy. Thank you.